So great first day, great presentations. I've really enjoyed this first day of presentations, and I know we have more great presentations coming tomorrow, more great content. So I have to admit my head was spinning a little bit after Ted's presentation here about all the different applications or possibilities with all the different mesh scales, etc. So yeah, basically, just real quickly, if I can go back to the PowerPoint slide. There we go. All right, so a bit of an eye chart, but just from a time line standpoint, what I wanted to do is just give you a little bit of background of myself. So I grew up actually in a family business. It was in the steel distribution industry, so the polar opposite of the high technology additive business I find myself in today. But really, after getting out of school, went right into that business. We had that business in our family for a number of years. We ended up making an emotional decision, but the right decision to sell that business after being in that business for 3 years. So I was sixth generation coming into that. It was founded in 1850 in Cincinnati. So we sold that business. I stayed with the company that bought us for 3 years in outside sales. And then my brother, mutual friend of my brother and myself, and I started a company called Morris Technologies in 1994. So back then it was the rapid prototyping industry, and there are a few folks that are here today and tomorrow that are from that era of the rapid prototyping industry back in the early 90s. And at that point in time, we started with stereolithography, so one of the polymer-based technologies. We also were involved in engineering design. So great journey. We organically grew our company over those years and added different capabilities. Really changed the game for us, though, in 2003 when we brought over a technology to North America called the direct metal laser sintering technology. So that was the first, as we understand additive metals, the first additive metal technology in North America. From that, we built our business, really focused on that, and built our business much larger. We ended up investing in multiple metal machines. We had a lot of capability on the back end, on the front end, developed a tremendous amount of intellectual property and know-how, and worked very closely with one of our largest clients, if not our largest client, GE Aviation, located also in Cincinnati. So, long story short is we, as GE started to use our company to develop in the early 2000s and accelerate their development of the LEAP fuel nozzle, we were intimately involved with that project. And you've seen a picture of it once at least, maybe twice today. So that project became really the central reason why GE Aviation ended up acquiring our company, both Morris Technologies and Rapid Quality Manufacturing, sister companies, back in November of 2012. So I've now been with GE for 5 years, and it's been a really phenomenal and fantastic journey. So originally, as I said, they bought us because they wanted to secure the intellectual property and they wanted to secure that supply chain for the LEAP fuel nozzle. But as time went on, they started to realize, they already knew, but I think they really started to go much deeper into, hey, we can use this technology far beyond just making some prototype parts. And in fact, if you look on that timeline up on the upper right, you'll notice that there's something called a CT or an ACT7 engine. And that project happened a couple years ago where some engineers went to the vice president of engineering, Mohammed Adeshami, who is now the leader of our additive group. And they said, look, why don't we take a small engine, something that kind of fits in the build envelope of today's technology, and let's just rethink everything about manufacturing of those components. And so they got a small budget. They had a very small team, less than probably around 7 or 8, maybe 9 guys. And they went off into a facility that was unmarked within aviation. And they spent the next 18 months to come up with designs and see how much of the design, how much of that CT7 engine could they actually go print. By the end of 18 months and 2 days, they had designed, they had printed, and they had tested an CT7 engine, of which 50% of that engine was additive. So just a phenomenal leap in thinking about how do we go from thinking that part level and pseudo system level into a much broader, much bigger system level thinking. So from that has led a whole ton of events, including our advanced turboprop engine, which is going to be a production engine, and that engine will be about 35% by weight printed. And you'll start to see that come out in a couple of years. So we get asked a lot, and I think those who talk about the technology, and you've seen this alluded to before, in this revolution, if you will, of additive, what does that mean for traditional manufacturing? And I think the right answer is that additive is certainly going to replace some components. We've seen many examples of that today. But traditional manufacturing is very complementary in many ways. And so I would say in our lifetimes, traditional manufacturing certainly doesn't disappear. And I'd also argue that additive is not going to take a major chunk out of things. If you believe that, call your number 13, 15, whatever, $1 trillion of global manufacturing output, how much does our industry make up today? I'd say it probably makes up less than 0.03%. So it's a teeny fraction of total global manufacturing output. Now, we believe, at least within GE, that this industry is on the cusp and on the verge of some explosive growth. We think that in the next 10 years, this could be a 70, 80, $100 billion industry. And why do we think that? We think that in large part because of the proof points that we see within our own business. So our aircraft engines, our transportation, our healthcare, et cetera. We actively use the technology on our products, and if we are an indication of the broader industrial market, then we think this is an industry about to explode. GE Additive was born. We have some pretty aggressive goals. We were born late last year with the acquisition of Concept Laser and with a majority interest in Arcam. We continue to grow. We're approaching about 1,100 employees in this little entrepreneurial startup within GE. We have goals to be about $1 billion in revenue by 2020, and in 10 years, roughly about 10,000 machines sold. We also internally have pretty aggressive goals to drive out about $3 to $5 billion in cost out of the organization using the technology internal to us. So Pete, that's a quick review of GE. My role today is a strategy growth leader. I get involved in a lot of different things. I wear a lot of different hats, but it's been a heck of a journey, 20-some years in the industry, and it's neat to see this kind of growth and neat to see this broad of application of additive in industry.
Thank you. This is not. Hello? Okay. Like I said, I'd like to ask a few questions, and so Greg doesn't know in advance what I'm going to ask him. And I guess to start, Greg, I'd like to ask you to elaborate on or maybe even defend the statement you just made. $76 billion, and I heard you say part of your basis for that is if we're representative of the rest of manufacturing, then that's where we think this is going to go. But you're GE, and so I don't know if you're, I guess I don't mean this entirely tongue-in-cheek, but is this additive stuff really for real? It took years and years to develop the fuel nozzle, a very early additive success to be sure. There are real challenges in getting a sophisticated part into repetitive production through an additive process. So talk about that. Is it true that the people who've invested in coming to this conference are investing their time wisely because this really is headed toward mainstream production?
So, look, I'm a pretty passionate guy about additive, so you're going to get a colored response from me, but I think it's a fair statement to say that I really struggle sometimes to think of an industry that makes something that isn't somehow using additive. And if they're not, maybe there's something out there, but you look at all the different modalities, all the different materials, and all the different application points, and it's hard to ignore it. I mean, it's really hard to suggest that additive is not going to be something that is a major disruptive technology to at least consider in some of people's manufacturing processes or industries. So I pick GE and I say, why is GE a litmus test maybe for what others will see? It's because GE is a multinational, very large corporation. It's a giant industrial company. It gets involved in a lot of different products. Again, from aircraft engines to train engines, if you will, locomotives, to healthcare devices, making CT scanners, oil and gas, you name it. So GE has a very broad industrial base in which it serves. Again, if we are an indication, the proof points we see internally as a corporation, we can clearly identify $3 to $5 billion of cost out over the next 10 years. That's a pretty big number, even for a GE. That gets the attention of a lot of people. So I look at that and I say, that's great. So from the cost out standpoint, I look and say additive is fundamentally making us think about our products differently. So just like the ATP, the advanced turboprop engine, will be 35% printed components. That's a fundamental shift in how our engineers and designers are thinking. When we can take 300 disparate pieces that make up a component of an ATP engine, and we can now consolidate that and make one part, you're thinking on levels that you haven't thought about before. So I get very passionate about the fact that I think it's a technology that may not be deeply applicable to every industry or to every company, but I think you ignore it at your peril. And I've seen too many examples of companies who haven't realized the gravity of it, and they find their competitors have been able to leverage the technology in ways they just didn't think about. So yeah, I think it's something that the people that are involved in additive here, they get it, and they're here to share knowledge and to interact with others. Those who are new to it probably might still be skeptical, but I think there are many convincing ways to leverage the technology, whether it's tooling, direct parts, prototyping, et cetera. It has a benefit to anybody who is manufacturing, and they really should be looking at it.
So you mentioned because of the perspective you have now as part of the additive team within GE, and GE is in so many different industries and sectors, and so you see all of these different possible applications of additive. So you're looking at a lot of different ideas in additive in a lot of different ways that it could have an effect. So given your expertise combined with the breadth of the perspective that you have, you have almost the very best view of where we are now in additive and what's coming. From the advantage of that perspective, what are some developments that you have seen recently or see on the horizon that come immediately to mind as things that could be really impactful for the prospects that additive manufacturing has?
So I think I'll just touch on two, and they've been touched on already through, I think, some of the other folks who have talked today. One is the technology advancement. So even though the technology has been out there for 30 years as we understand it, I think we're still at a relatively low on that technology curve. So I would expect to see over the next coming years pretty good advancements on the technology around the machines, for instance. And that's a big one, because if you get the throughput up substantially, the circle of applications grow exponentially. So if your circle is this today, you get 3 or 4 or 5x the speed and throughput of some of these technologies, in particular, say metals, then you start to open up the range of parts that will fit from an economic standpoint dramatically. The second thing I'd put out there is, and we haven't talked maybe as much, although Ted talked about it recently on topology and some of the optimization of CAD, but the change in engineering thinking is starting to accelerate. And that's really, really important. You need all the other things. You certainly need to have capable and competent machines, and you need to have the quality controls associated with those, and you need to have the material curves understood. You have to start with those basic building blocks. But engineers and designers, if they start to become much more familiar with how I think about design, how I think about additive, and what does it mean to my products, then you end up getting to that perfect state much faster. And I think companies will win. The ones who have that larger population of people that have been able to transform their thinking into an additive way of thinking have a better opportunity to win leveraging additive than those who are just trying to take the apple and make an additive apple. You want to take the apple, the orange, and the banana to make your new fruit. and that's really what additive's power comes from.
Okay, so the prospect of these engineers who are willing to make the new fruit. I guess reaching back to the time when you were an independent business owner, what perspective can you bring and what sort of insight or advice can you offer to the independent manufacturer who maybe is investing in additive, maybe is growing some ability in that capability, but they're faced with the challenge of they need customers who are willing to engineer parts that can really take advantage of what additive can do.
Yeah, if I understand the question, I'll try to answer it, I guess, in a way that I think I took it, which is for the smaller businesses or the businesses getting involved in it, I think you have to find the niche that fits best for your business. You know, not all sizes are going to fit everybody. And you saw, again, from a few of the slides, there are a ton of different modalities, a ton of different ways you can leverage and use the technology. It can be as simple as I want to use it internally for efficiencies of fixturing or what have you, or tooling, or it could be more complex where I'm going to go get a modality or I'm going to buy additive, buy into additive, I'm going to go out to my customer base and I'm going to say I've expanded my capabilities and now I've got additive as well. And look, it's not easy. I think those who jump into the game of additive, and depends on what modality and what materials, but it can be challenging. And if you deal, for instance, with a GE Aviation, there's a lot of potential coming. But to become an additive supplier for the aviation industry, the bar is pretty high. It's high not just in your knowledge of how do you operate the machines, but you have to have a lot of things in place from a certification standpoint, from a process standpoint, from a knowledge standpoint, in order to really be effective as a production supplier to, say, GE Aviation for gas turbine engine components. So a pretty high bar. Same thing with implants. You're going to have a different type of sequence of events you have to go through and certifications, but that bar is pretty high. There are industries that are not as high of a bar, and that was touched on as well. But I think for the smaller companies, there are a lot of ways to enter. It doesn't have to be I put all my chips on the table. And admittedly, I mean, these are pretty expensive machines. I mean, you think about $500,000, $1 million machine. I could go buy 2, 3, 4, 5 lathes and mills and keep going with my traditional technologies and probably do well. So it's got to be a purposeful decision. I would also say I think you have to be very committed. So it's very easy as a traditional manufacturer to get involved in new technology, find out it gets tough, and when it gets tough, you fall back on what you know. And to really cut that cycle, you have to make some tough decisions while things are not going well, because that's where you learn.
You have to remain committed, and I'd love to hear you elaborate on that a little bit more. Maybe, so there's somebody sitting in the audience who is they are an established, successful, conventional manufacturer. They're in plastics, they're in metalworking, but they get it, and they're persuaded that, yeah, big changes are coming as a result of additive. I have to invest in this and develop this. I have to get some capability here. What is the path going to look like for them? What are some potential challenges for them? What advice can you offer as far as what it really looks like to stay committed to this technology?
Yeah, so first I would say just, if I'm putting myself in someone's shoes like that, it can be daunting. It can be something you look at and say there's a lot of learning. I feel like there's a ton of people that are way ahead of me, what have you. I think just having this kind of an event is very helpful. I think you can tap into a number of resources, so you don't have to jump in necessarily with going out and acquiring that piece of equipment that's very expensive. You can take your learning curve at a controlled way. So you can tap into the different, say, Oak Ridge National Labs and their center that is a beautiful place to be able to go, or some of the other type of institutes that are around the country or around the world for that matter. There are service providers that are people that, they have the equipment, they have the knowledge. And I think this industry, one of the things that's pretty neat about it, are people are willing to share. They're willing to talk about their capability and help people come up to speed. And if you believe, again, $7 billion today and say 70 or 80 billion in 10 years, there's a lot of room for a lot of people, and there's going to be probably a shortage of supply, not a shortage of demand. If you believe those numbers. So my point being, this is an industry that historically has been pretty welcoming and pulling people along and trying to help them understand how do you come up to speed on the technology, whether it's through trade shows, service providers, institutes like Oak Ridge, et cetera. If you choose to go this route, it is a choice. Nobody is saying that the business that one is in is bad. And again, I would suggest that if you have a very successful business in traditional manufacturing, it's not going away. You're probably going to find that your business is great. It's thriving. It'll grow. Additive might just be a means to broaden the offering, broaden the capability, and hedge against what maybe some of your OEM customers might start to do with the technology. There's nothing wrong with a wait and see attitude, because there are so many modalities and there are so many different technologies that are coming along and that are maturing and developing. So I don't think there should be an urgency. Ironically, I felt in 1994 like we were too late to the game and everybody was involved in additive. Flash forward 23, 24 years, and I realize today that was an irrational fear. And I'm glad we got involved when we did, but I don't think I had to feel like we were already too late. And I would encourage people not to feel like they're too late. Start to experiment, start to see how you can affect your own business in a positive way, and then see strategically where are the opportunities that your business can go. And I think spending the time to really think strategically versus tactically is going to be pretty important as one determines where do they want to jump in, how do they want to jump in, and how committed are they going to be.
So that's an interesting tension I'm hearing you articulate, because you seem to have said earlier, this technology is undoubtedly significant and deserves your attention and engagement, but you're also saying, but there's no need to panic about it and there's no need to rush. Am I being fair?
You're calling me out. Yeah, no, I think you're being fair. I'm saying both things. Again, 0.03%, I'm just going to use my numbers back again, so 0.03% of total global manufacturing output. If it got to 0.5%, that's a really, really big number. It's still 0.5%. And 99.5% is still traditional as we think about it. So I think every business has to make the decision about whether they feel that there is a threat to their current existing way of doing business or their technologies they use or not. And then on the flip side of that, on the other side of the coin, is the opportunity side. And maybe additive is a way to substantially grow their business. Maybe it is a way to incrementally grow it. So yes, there is huge opportunity, but I also am sensitive to the fact that I think a radical left turn on your business is not maybe the right answer. I think sometimes taking the appropriate amount of time to evaluate and really see what impact does this have. And do it with an open mind. If one goes into it where I'm going to prove this additive stuff's a bunch of crap and I don't need to get involved in it, yeah, you're probably going to find that it's a bunch of crap. But if you approach it with a viewpoint of I'm curious and I wonder how this might affect me, negative, positive, and I should be aware of it, then I think that's the appropriate way to approach it for those who are not currently involved. There are just so many mechanisms to get more involved and to learn more, and my encouragement is learn more, find out what others in your industry are doing, find out what your competitors are doing, find out what your customers are doing in the space, and then learn more through trade shows and a bunch of other avenues. And I think that will ultimately lead one to strategically, where do I take the business? Yeah. And again, I can't emphasize enough, I think it's strategic, not necessarily a tactical decision all the time.
All right. Well, okay, so speaking of where do I take the business, So GE is a committed and leading user of additive manufacturing, and we're seeing GE realize benefits from its use in all kinds of ways. But GE has also made recent acquisitions that make them a leading supplier of additive manufacturing equipment. And those acquisitions represent a big change in what is still a relatively small space. What is GE's aspiration in this area as an equipment supplier, as a technology supplier? Is it good for this space to have GE in that role?
Yeah, so I'm employed by GE, so with the lens of GE I would tell you, yes, it is very good. And here's why. GE has invested $1.5 billion in the controlling interest of Concept Laser and a majority interest in Arcam. Since that time, we continued to spend really a fair amount of money in building up the organization in technology and advancing things. So the first thing I would tell you is, even though we see the benefit for these technologies internally, this is not an internal GE play. This is a play where GE is looking to have this become the next GE Aviation or GE Energy or GE Healthcare or Transportation business. This is going to be a vertical business within the GE Corporation, selling machines, selling materials, and engineering consultancy services. So, we look and say we will probably over the next 10 years, consume maybe 5% of the equipment and that GE Additive produces, and 95% we anticipate to sell out to the broader market, to anybody. Okay, even traditional GE competitors. So we have a very clear focus of where this technology is going. And why is it important GE is involved in it? I think the answer is it brings validation to an industry that has emerged from being a rapid prototyping industry to maybe 10 years ago starting to talk about additive manufacturing and really taking that pretty big leap from prototype into production. So GE has validated that. In our Auburn, Alabama facility, not terribly far from here, we are in production on those field tips. In Europe, we will be in production on those 35% of, which is 12 or 14 components for the advanced turboprop engine, and on and on. So we have a number of examples where we have gone through that industrialization process. We have been able to control the machine and the technology to the point where we know we can fly these components. And today, we're flying 300 plus engines, and that number goes up every day, that each one of those has 18 fuel nozzles in the engine. And so we are actively flying a bunch of people around, and that kind of confidence doesn't just happen overnight. So to me, it validates that this technology is ready for prime time. It's more about building the case economically. Is it ready for prime time in every industry? No, not yet. But I think we're finding that is starting to, as I mentioned before, the technology curve is steep, meaning we will see a lot of innovation. We will see machines speed up. We will see all of this start to happen over the next 5 to 10 years, where if you have the foundation of industrialization already there, now you're making the economic case that additive is good to go that direction.
All right. Thank you for that discussion. So I'm gonna, if you'll stay with me, I'd like to ask some other succeeding users to come back to the stage. I hope they're still here. If Eric Johnson of John Deere would come up, Mark Morrison from Smith & Nephew, and Jarod Rauch from B&J Specialty. Speakers you've heard from today. And in addition, I'd like to ask up one speaker you haven't heard from yet, because he's speaking tomorrow, Adam Clark from Tangible Solutions. Tangible is a Dayton-based, ISO-certified contract manufacturer in the medical industry. Greg, if you would kick things off, is there a question that you would put before this group of users for them to elaborate on?
Sure. So first off, I've enjoyed the 3-year presentations today, and Adam, I'm going to enjoy the presentation tomorrow. So everybody will. So look, I think you guys come from a little bit different areas. Obviously, we have John Deere, we have Smith & Nephew, BJ Specialty, and Tangible, and you guys have a different background. So I made a bold statement from a GE lens, and GE is, again, a different company than the 4 of you guys. I'd just like to know each of your thoughts. Is Greg out there drinking some kind of Kool-Aid that you haven't had yet, or am I hitting the target, do you think? I mean, what in your world, how do you view it in your world? Do you see it being as significant as what I was just kind of saying, or do you think that I'm overblowing it, or do you think I'm underestimating it? We just go down the line.
Sure. So I can take that. Yeah, I think it is going to be a game changer. It may just be a little bit delayed from the cost curve of what the aerospace will be. I think you probably have similar size, maybe not as large as structure-wise, but maybe that isn't an application that goes forth. But yeah, have we put a number to it? To put a number out there, not totally sure, but it'll change the game.
Yes, so I think that we're not anywhere close to even seeing additive take over subtractive. I think today you need the right application to take advantage of what additive can bring to the table, and honestly to tolerate the higher costs that come along with it, particularly with metal and all the post-processing and things like that that come along with it. So it's a matter of finding the right application in your field, in my opinion. I think a lot of people that might know just a little bit about additive think we're going to start making everything, we're just going to print everything, and it's not feasible, and I don't see that being feasible for most things for a very long time.
I definitely agree with all of those statements. I view additive in the molding environment as just another tool for your arsenal of how you can manufacture. We have all discussed, finding the niche, finding that perfect place for it. But if you, have an open mind from a designer standpoint, you're much easier going to be able to apply it to your line of work, whether that's in the molding, medical, aerospace. There's additive can be used for about anything if you apply it correctly, and I think that's why a lot of us are so excited for where additive can go in the next 5 to 10 years. But yeah, I mean, it's not going to be a replacement of how we typically manufacture things. It's just going to aid us to make that next step.
Well, I've had 2 glasses of Kool-Aid, and I'll probably have a third before I leave today. I think it's, I've staked a lot on it, and my business partners and I and our investors and our board and where we're going and what we're doing. I think what's really interesting that I watch is the maturity of the industry, not necessarily of the technology itself, but of companies, of processes, of delivery. Within additive, we're starting to see subcomponents and focused groups of companies focusing in on target markets, target products. We started out with 2 printers in a garage, and now today we virtually only do 90% of our business is titanium implants. We call ourselves a contract manufacturer of spinal implants, and that's our focus. There are other companies out there that do aerospace really, really well. I think as you start to see that proliferate, you start to see those 4 to 12th graders start to enter into the workforce and see more of the technology being used. It's going to accelerate at an exponential rate that will be difficult to keep up with, and I think it's really important that us as a whole, as an industry, come together and prepare for it so we can make it a $76 billion industry, because it certainly can be.
Greg, I'm particularly interested in your aspect in the GE model for this. Now, GE can do what they want with their designs and design materials, design processes. Their ball field, they can do what they want. Have they created designs specifically for additive manufacturing instead of, well, this part can be made out of bar forging or made this way? Are they anticipating opening up that kind of manufacturing process to legacy parts, or is it only go forward, we're designing parts, and this is the process we do it? And by the way, are they doing it all, internally, or are they doing this with the mindset that their supply base would be buying this equipment, using this equipment, and operating it with the GE design materials specifications?
So a lot of great questions there. So first off, yes, GE has gone down the path of specifically designing new components for new engine programs in the case of aviation with additive in mind. So whether it's the LEAP engine, our 9X engine, the advanced turboprop engine, and so on, some military programs, we have specifically designed additive into those parts. So they would not be capable of being produced in a traditional manufacturing methodology. and I may not remember all the questions, but you had asked about suppliers and whether we are internalizing it. Well, initially, GE Aviation did internalize it because we felt there was a tremendous competitive advantage. We were trying to be a little bit quiet about what it was that we were doing. But even a GE, as large as a GE is, will have their constraints on capital equipment and other expansion type capabilities. So there are a lot of technologies that we have. Additive's one of the technologies. It's a big one within the corporation, but there are a lot of other ones they have to invest in as well. So I think we will continue to invest heavily in having our own internal capability, but without a doubt, GE will also be starting to look for external suppliers to help them both on our new product introduction or NPI hardware as well as on our production hardware. How that rolls out will be up to aviation and our supply chain within aviation, but I would for sure look in the future to see parts being produced outside. And that will take some GE help. That'll take some of the aviation parameter-specific type of knowledge and know-how and agreements in place to be able to go out to those suppliers and make sure that they meet the requirements that we know are going to be necessary in order to buy into the material curves that we've spent a lot of time and money developing. So I don't know if anybody else want to comment on that, maybe similar in your organizations or suppliers, outside suppliers, or internal?
Smith & Nephew has made a strategic decision for it to be a core competency for us. So we've developed all the software behind the product I shared earlier was all developed in-house, and we print in-house. So yeah, we've kind of taken the opposite view, I'd say.
So real quick, another element of your question is that you're right. As an OEM, we own the design. Okay, in this case. Now, there are components we buy where the vendor owns the design, and they would then have to certify that design and take that their own path, probably in a collaboration with GE. But without a doubt, if you own the design and you have it that you want to produce it in a certain way, aka additive, then you hold a lot of those cards. But so one of the questions is for suppliers, well, how do I differentiate? If you're telling me here are my parameters and here's the design, how do I differentiate? And I think there are still a lot of ways. It's not the point on this particular question maybe to go deep on that, but there's still a lot of ways to differentiate as a supplier. But clearly owning the designs and having the design knowledge will only mean that we tend to leverage technology to our product advantage, and so I would expect to see more and more parts that we look at maybe go from being a casting, in some cases even a forging, into an additive component.
In one of the recent talks I'd heard from GE, I think one of the focuses that you've put on is performance driven versus we're going to make this out of additive manufacturing. More so, I need this extra performance, and the only way I'm going to get it is with these designs, and these designs can only be made additive, versus saying additive, right? I think that was a change of thinking for me during that talk.
Yeah, no doubt about it. And look, if you approach it where everything you want to produce it should be an additive part, then you're approaching it wrong clearly. And so it has to have some performance advantage. Which for us in most cases is going to translate into a cost advantage. So it's more difficult to kind of answer the final one I think I missed, which was to go back to legacy engines and try to suggest I can replace those legacy components with additive. It's a lot more difficult to do that for a variety of reasons. It's much easier as we look at new platforms and new programs to incorporate additive into the next generation of engines versus trying to go backwards.
Hey, Justin, I caught a question over here. While you're going over there, I guess we've talked about technology, we talked about process, design, technical challenges. Once you make the commitment to additive, is there a personnel challenge with that too? Is there a skills and or mindset and or talent type issue that goes with that? Like if that, I'd like anybody to speak to that who has a thought there.
I'll jump on that real quick. I look at manufacturing as kind of like a unit, just manufacturing in general. I think I'm a veteran myself, but I do see a lot of similarities between manufacturing and the military. the reason I bring that up is because what I'm seeing in additive manufacturing now is more discipline for production, and kind of to the point before of using external suppliers or internaling it. I think a lot of companies and OEMs are internalizing some of their builds because you can't trust that supplier base. You just can't. We've had our hurdles that we've had to overcome, have many challenges, and I'll be brutally honest about them all tomorrow, because there's a lot. But you're starting to see maturity, and with maturity comes experience, and with experience comes discipline. And as you start to see the discipline, you start to see the workforce come out. It's about taking, and I see it too because we have millennials. Everyone talks about it. I don't really see it as long as they're given the proper guidelines to deliver, and you're timing them, and you're making sure everything's staying on a schedule. It's a totally different beast from what we've known for 50 years when it comes to our scheduling and product and shipping and vendors. And it's about developing that vendor network, even for us, and going and educating them and saying, this is what to expect and this is what we expect back from you, and this is what's going to happen, and here are the challenges. So developing that whole ecosystem comes with the personalities, understanding it. They say every company needs a company dick, the guy that's going to be going around and just, bouncing on the table and telling everyone what to do and where to be. And excuse my language, sorry. I apologize. Sorry, Pete, my bad. So anyways, back on point, you got to have that personnel that's going to go around and keep everyone on point, and we're starting to see that, and we needed that as well. We were, back in the day, it was two guys in a garage bouncing around with headphones in, whipping out parts to some of our local customers, and it's not that case anymore. We had to change ourselves, the way we looked at the industry, the way we wanted to be presented to our customers, and then we just needed to recognize that we didn't know what we didn't know, and we needed to bring in the proper type of board that had 30 plus years of manufacturing experience to show us how to take new technology in a new industry and apply the disciplines of traditional manufacturing to make it work, and to make it work like American manufacturing should, and that's with excellence and quality. So it's kind of a personnel of new age, old school way of doing things and combining it all together. And if one of my board members was here, he'd be really happy I'm talking about this right now.
Later I'll tell you who has that title in our company.
Yeah.
So coming from a supplier point of view, do you feel that from our customer base, do you feel there's a difference from the customers based on geography versus America, Europe, or Japan, that they're more willing to take on additive manufacturing parts?
Does the willingness to embrace additive vary by culture or continent? Have you observed anything like that? You're nodding yes.
Yeah, I'll just quickly say I think I've seen that. If you look, a lot of metal additive has emanated from Europe. A lot of very solid, good German companies and other companies in Europe have developed the metals technology, for instance. But interestingly, I think the U.S. was a little more advanced relative to how do you use the technology for making parts. Now, so I would say there is a little bit higher tolerance for risk here in the U.S., and you find a little less in other regions of the world. But, as U.S. Typically has demonstrated some of those things, I think you see people quickly coming up to speed and leveraging the technology on an equal footing today. But, I think you get elements of it. I think it's not a broad brush, but I think you do get elements of how much creativity is one culture or one country able to apply using this technology versus another. You have differences in countries on amount of government investment and the type of investment that governments are looking to push into additive. A lot of that is directly related to their view of what additive can do for their economies, et cetera, et cetera. But for sure, I think different cultures and different countries will have different flavors, if you will, of risk and of applications that they think about.
So the question, if you didn't hear it, the life of an injection molding tool that is made additively relative to what you're accustomed to?
Right now, the main focus when you do talk about wanting to apply conformal cooling into your designs is within the infrastructure of that conformal line itself. geometrically, if you have knife edges, you start to create stress risers internally that could, down the road, potentially be an issue. So, just like you would think of externally, not having those 90-degree corners that could potentially be a breakage point, you kind of have to think that same way internally. We see a lot of that, leading to success for longevity of a part. It's just the thinking internally with the importance of geometrically what your structure has to look like.
So if you do things the right way, what kind of life expectancy have you seen
From what we have been doing so far, we're seeing 1-in-1 life, the life of it. So, thank you.
So kind of going back to the previous question, I have seen Europe on the tooling front seem to be pretty active and leveraging the technology and tooling, probably more so historically than the U.S., which is interesting. But it actually kind of leads me to Jarod. I didn't get a chance to ask in your presentation, but who drives the decision to go to an additive tool? Because my understanding has always been that the OEM, like a GE, but not a GE in this case, would basically say, you got to guarantee me 10 million shots off that tool. And the incentive for you to go and put conformal cooling into that to save them cycle time is pretty low. And I think that's been a disincentive, actually, for the technology to make its way into the mold building industry. Do you see that, or do you see it as being a different path?
If I heard you correctly, as far as ultimately who makes that decision to use additive, I'm going to say at this point it's a 50-50. It's a group commitment. A lot of times right now, presently, within the molding environment, in the molding world, they're eager to listen to what additive is, but they're very hesitant to make that decision, to want to go that road, to take that path. So that's the reason why, utilizing your engineering skills and utilizing your software from an analytical standpoint to be able to show these case study results and testing, is key. Because it's all about, at the end of the day, it's all about making money. The customers want to see that bottom number. They want to see that they're, increasing productivity and making things faster, going to be able to make more parts and make more money. And, with additive applied correctly, that is definitely something that can happen.
Thank you. We have a number of university courses and books on design for manufacturing. Do we have anything like that for design for AM?
Recommendations on books or other media on design for additive. How do you begin to understand the design issues in additive manufacturing?
A lot of the manufacturers have design guidelines that they will share with you. I'm not aware of any collegiate textbooks or anything that cover it.
Is it accurate to say the lack of that kind of concrete kind of textbook compilation is a missing piece? Am I fair in guessing that there are design rules to additive manufacturing that you've learned by trial and error?
Definitely.
Yeah.
It's a huge part of it. I mean, just support structure alone and how you orient the part. There's a real art to that, and it's often empirically learned, and there's no great guides that tell you exactly how to do it.
So the textbook is failed builds.
Mm-hmm.
Yeah, that's true.
Yeah. Yeah, I mean, you can get as organic as you want in a design. I think you have to look at the application. If it's a block because it's cheap to make a block, then leave it alone. But if you're trying to make that block super organic, and then, oh, by the way, you've got all these support features that you have to mill off, and now you're talking about consistency and, conformance all the way through, and potentially something, 1,000-part order, you start to run into issues. So, it's when you think design, don't just think AM. You have to think downstream operations. What other post-processing equipment is this build plate and this part going to touch? because if you start orienting parts all over the plate, think about, stacking a build plate with the same part and going through on a 5-axis through 3 or 4 parts at the same time. Getting that experience. So when people say design for AM, one-off art pieces are great, but if you want to talk production, you got to think holistically, lot consideration all the way through of the parts and handling them, and what it's going to take to actually finish them, because we were shown support structures that are pretty much solid, and we said, well, for our business that doesn't make sense. Why do we want to go solid? We might as well mill it. I can get into the details on that later, but the fact is that we wanted to get into where we could do some hand remove. So we started playing around with support structures, and just like you're saying, it's an art form. You've got to just start building it a couple of different ways in the same build plate. Everyone take a look, huddle up, 5 minutes. Let's make a decision where we're going to go, and then fail. Find where you're going to fail, and then you'll find that success point. It is trial and error, but I really, really caution everyone, especially on the metal side, to think downstream. Think downstream. Don't stop your thought process at the machine because you will fail. Been there.
Sounds like you had a comment.
Yeah, just real quick. It's a great question, and unfortunately it's a very complex field. So there are so many modalities, there's so many different materials, there's so many parameter differences. So I think we're starting to see more of the basics of additive design for additive. But clearly, it's going to be at a high level. So, simple things like you can do snaking passages versus straight hole passages, and, a little more sophisticated than that, perhaps. But when you really get into the nitty-gritty, I think you start to zero in on what modality am I going to be talking about, what kind of materials am I going to be dealing with. There are a number of groups that have courses in the basics. There's starting to be more that come out. There are books that are out there. I can't think of the ones right off the top of my head. Universities and, of course, the OEMs of the equipment, I think, have some courses that each of them would probably say we offer to help our clients and our customers get up to speed on the fundamentals of design for additive. But to get really deep, it's developing, and the schools are starting to teach it, and we're starting to get there, but we're a ways off before you really can say, I want to go pick the textbook for this modality and these type of materials and be able to come away with a solid understanding of that. Most what you'll hear is a lot of trial and error and tribal knowledge at each company that helps to get their engineers and designers moving along the right path.
Pete, I've heard that there's a tremendous trade publication covering those exact things.
Pete, I think we have time for about one more question, and we have one back here.
All right.
I have a question, I guess, for any of the panelists. What percentage of your business today is utilizing additive manufacturing to make parts, and what is the impact percentage-wise on the bottom line today? And what do you expect it to be in 5 years, and what do you expect it to be in 15 years?
I can start off with we're 100%, have been, always will be. We do have machining capabilities, but that's to support our additive operations. When we were first getting started and opportunities come in with a customer that you're printing parts for, and they say, hey, can you mill this, can you do that? And you consider it for a minute, but then you think about, well, I've got parts coming off, they're going to need to hit that. You just, you got to say no. And so for us, it's 100%. And I think you're going to see a lot more tangible solutions start popping up, and just service bureaus throughout that have, a deeper focus. Just like, when you walk through downtown Dayton, I mean, it's humming. There's probably hundreds of machine shops. I mean, you're going to see towns like that, like the Dayton, Ohio's, and the Huntsville, Alabamas of the world, and the Knoxvilles of the world that are going to start having these providers be able to produce parts in mass, and Honda's going to be able to go to several different suppliers across the United States to get the same component and feel like they're getting consistency, even from supplier to supplier, no matter what machine those parts are coming off on. So, I don't even know if I answered the question, so I hope I did.
Jarod, your thoughts on percentage impact of additive and what you expect it to be in the years down the road?
Right now, presently within our company, additive is actually a very low number, but we view additive as the next step that we want to take if we want to continue to be competitive with our field of work, because we see the potential for where it can go. If I had to put a percentage on it, I would say at this point it's probably 1 or 2% at the most. Because our background comes from high-speed machining, 3, 4, 5-axis machining, conventional manufacturing across the board. But with the use of additive, this allows us now to offer our customers something new, something better that can, in return, make things better for them. So, it's in the next 5 to 10 years with our company, I see that, tripling or even more as far as, how much of that work is going to be strictly additive within B&J.
Mark, you spoke about surgical guides. You're also making implants this way in some cases.
We are.
I'm particularly curious about your take about the 5 or 15-year time frame.
Yeah.
Ultimately, what could this be for Smith & Nephew?
Yes, I would say right now, roughly, we're probably at about 1% of what we do. And that is growing, but slowly. Timelines in our business are long. So a development project might take 2 or 3 years. So 15 years, and on some products, because of regulatory issues, it could stretch out to almost a decade, believe it or not. So in 15 years, I'd be shocked if we were any more than 10%, but that's still a significant amount of investment, I would say.
I really haven't looked at it from a whole part, but from a tooling aspect, we save about 5% today over traditional tooling. That's internal tooling, that's not conformable cooling or injection molding or any of the external things. And it could probably be 50% of what we do in the internal tooling in about 10 years.
So I think for GE, it's a fraction of a percent of what we spend in our supply chain today. It'll be substantially larger as we go forward. I would just point out that I think the impact is not just GE, though. It's really our whole supply chain. So if you think about 300 pieces that were cast and machined and brazed and welded and assembled, and the number of engineers and designers to create those 300 pieces, and the miles of travel that all those pieces had to go, and the number of pieces that had to be existing within the supply chain just to make sure we met delivery, and now I can print one part that has that same functionality as those 300, then the impact is relatively large. So I think that's what we see. So I would tell you that, again, today there's 12,000 parts that make up a LEAP engine, of which one part, 18 of them, is a fuel nozzle, fuel tip component of it, and the ATP will have 35%, as I said before. The GE9X will have fuel nozzles. It'll have the low-pressure turbine made out of titanium in the EBM process. So our use and application and really total view of additive is only going to be growing exponentially as we go forward with the GE Corporation.